Squares and square roots. Patterns in square numbers. Observe this number series. Every number series follows a certain pattern. In this, the series starts with 1, and from there we are doing plus 2, plus 3, plus 4, plus 5, and so on. Every number can be represented with the help of dots, and the dot pattern of a number can be a line, square, rectangle, or triangle. All these numbers given here. For these, if we write the dot patterns, they look like triangles, and so they are called as triangular numbers. Now, when we combine any two consecutive triangular numbers, it looks like a square. Now, let us combine the first two triangular numbers. In that case, the pattern will get changed like this. In this, we have four dots, which means this represents number 4. 4 is nothing but 2 square. So, combining two consecutive triangle numbers is giving a square number. Let us observe for another two numbers. Now, when we combine the second and third, it looks like 9, and 9 is nothing but 3 square. So combining second and third is giving 3 square. Similarly, when we combine third and fourth triangular numbers, they give 4 square. Now 6 and 10, they make 16, which is nothing but 4 square. Similarly, fourth and fifth, if we combine them, they give 5 square. From this observation, we can generalize that when we combine two consecutive triangular numbers, it gives a square number. How to apply this concept? When we have any perfect square and that has to be written as sum of two triangular numbers, we can use this. Here we have 64. 64 is a perfect square. Square number means when we can write a number as a product of two numbers wherein both the numbers are same. So 64 is nothing but 8 into 8 or 8 square. So this 8 square should be represented as sum of two consecutive triangular numbers. When it is 8 square, we have to take 7th and 8th triangular numbers. But how to find which is the 7th and 8th triangular number? For that, we have a formula. To find any nth triangular number, we can do n into n plus 1 by 2. Now, using this formula, we will try to find the 7th and 8th triangular numbers. Just substitute the value of n in the formula. So when we say 7 into 7 plus 1 by 2, it gives 28. Similarly, on substituting 8, we will get 36. 28 plus 36, if we do that, it is 64. So 64 is a perfect square and we have written it as sum of two numbers. So let us take the dot pattern of these two numbers and see whether it's like a triangle or not. Here are the dot patterns for 28 and 36. They look like triangles, so it's a triangular number. Coming to the next pattern, two and non-perfect square numbers between the square of two consecutive natural numbers n and n plus 1. We'll understand this with help of an example. Let us take n equal to 3. N square means 3 square, that is 9. N plus 1 square means 4 square, which is nothing but 16. Now, when we count the numbers between these two, that is 9 and 16, we'll just try to count how many numbers are there. And all those numbers are non-perfect square numbers as they can be written as square of any other natural number. So between these two numbers, we have 10, 11, 12, 13, 14, and 15. So they are 6 in count. Between n square and n plus 1 square, we have 6 non-perfect square numbers. So as per the pattern, whatever we have learned, there should be 2n non-perfect square numbers. Let's substitute the value of n here, that is 2n means 2 into 3, which is nothing but 6. So in both cases, we have got 6 non-perfect square numbers between 9 and 16. Coming to the next pattern, sum of first n odd natural numbers is n square. Let us take a value for n. If it be 5, let us list the first 5 odd natural numbers. Here are the numbers 1, 3, 5, 7, 9. We'll take the sum of these numbers, and on adding these we will get 25 as answer. So sum of first n odd natural numbers is n square. Let us do n square. N is 5, 5 square is 25. In both the cases we have got 25. So this pattern is observed in square numbers. Coming to the next pattern, square of any odd natural numbers other than 1 can be expressed as sum of two consecutive natural numbers. We'll take any odd number that is other than 1. Let it be 3. So the 3 square is 9, and 9 can be represented as sum of two consecutive numbers. As it is a small number, we can easily identify that to be 4 plus 5. So 9 equal to 4 plus 5. Square of odd number, that is 3. 3 square is 9, and it is represented as sum of two consecutive numbers. But for bigger numbers, how to find which two consecutive numbers form the sum? For that, there is a formula. Here the first number can be found using n square minus 1 by 2, and the second number using n square plus 1 by 2. Let us take any another value. Let it be n equal to 11. 11 square is 121. So 121 has to be written as sum of two consecutive numbers. The first number, we will use this formula n square minus 1 by 2, that is 11 square minus 1 by 2, and the second number is n square plus 1 by 2, that is 11 square plus 1 by 2. Substitute the values, and on simplifying this, we will get 60 plus 61. 121 equal to 60 plus 61. 60 and 61 are consecutive natural numbers. Product of two consecutive even or odd natural numbers is equal to 1 less than the square of only natural number between them. We have to take two even or two odd numbers, and we will try to verify this pattern. First we'll take 12 and 14, both are even numbers, and we'll find the product of these numbers. It is 168. This product should be equal to 1 less than the square of natural number that lies between these. So between 12 and 14 we have 13, and when we take square of 13 it is 169. 1 less than of 169 is 168. In both the cases we have got same answer. Let us validate this with help of odd numbers. We'll take 11 and 13 now. Product of these two is 143. The one and only one number that lies between these two natural numbers is 12. 12 square is 144. 1 less than square of number between them, that is 144 minus 1 is 143. In both the cases it's same. So with that we have validated the fifth pattern as well. Apart from these patterns, there are some other interesting patterns as well. Square of natural numbers having all digits 1 will follow this particular pattern. Here if we observe, we are taking 1 square, 11 square, triple 1 square, like this. So all digits in the number are 1. While doing square of such numbers, first we have to count the number of ones in that particular number. To write the result, we'll start with 1 and continue writing the natural numbers till that particular count in ascending order. After that, in descending order, we'll write till 1. Let us observe this. Here we have 4 ones. So we'll start with 1 and write till 4. 1, 2, 3, 4 in ascending order, and then in descending order till 1. 3, 2, 1. 1, 2, 3, 4. 3, 2, 1 is the result. This is applicable only when we have at max 9 ones in particular number. So this 9 ones number is the last one. The answer of that we'll have to write from 1, 2, 3, 4, 5, 6, 7, 8, 9, and in descending order 8, 7, 6, 5, 4, 3, 2, 1. Coming to the next pattern, when we have 7 in ones place, 7 square is 49. When we have 7 in ones place and remaining digits are 6, in that particular case, to write the result, first count number of 6 we have in the given number. Increment that value with 1 and write those many number of 4s, and then write 8s, the count of which should be equal to the count of 6. At last we have to write 9. Let us observe this. Here it is 4 sixes and then we have 7, and we are trying to find the square of that particular number. We have 4 sixes here, so in result we should write 5 fours and then 4 eights. At last write 9. So this way we can use this pattern to write the result easily. Now coming back to the 11 square, 121. When we have 0 between two ones, even in the result we will have to write 0 between those digits. 101 square, 10201. So the number of zeros we have in the given number, the same number of zeros we have to write in the result also. Similarly, when we write 101, again 01 square, like that, in this case we are adding 0101 so many number of times. Observe this number. Here we have 4 ones separated by 0. In the result also we have to write from 1 to 4 and again from 4 to 1 in descending order, but every time we will separate these digits with 0. Coming to the next pattern, it is 4 square is 16. When we have a number with 4 in one's place and remaining digits are 3, to write result of such a number, first count the number of threes in the number. In the result, we will have count plus 1 number of ones, and then 5's equal to the count. At the last, we'll have 6. If we take this particular thing here, we have 4 threes. So in the result, we should have 5 ones, then 4 fives, followed by 6. This is another pattern when we have a number with all nines. 9 square is 81. When we write a result of this particular thing, first we have to count total number of nines, count minus 1 number of nines in the result, followed by only 1 8, and again count minus 1 number of zeros followed by 1. Let us observe this. Here we have 5 nines. So in result we should write 4 nines first, then 8, 4 zeros, at last 1. In this way, we can use these patterns to identify the squares easily. There are so many patterns, but here we have listed only few of them. In this video, we have seen that combining two consecutive triangular numbers gives a square number. There are two and non-perfect square numbers between the squares of two consecutive natural numbers. First, n odd numbers sum would be equal to the square of n. Square of any odd natural number other than 1 can be expressed as sum of two consecutive natural numbers. Product of two consecutive even or odd natural numbers is equal to 1 less than the square of only natural number between them. Along with that, we have seen some interesting patterns in squares.